In this video, let me consider one numerical on Norton's theorem. Find I0 in the circuit shown below using Norton's theorem. This is the given circuit. We need to calculate I0, that is current through 2 kilo ohm resistor using Norton's theorem. So this is the given circuit. We are supposed to calculate this I0. So in Norton's theorem, the branch in which current is calculating, that branch supposed to be short circuited. Now I will remove this 2 kilo ohm from the circuit and I will short this circuit. So the circuit looks like this. The current through this shorted path is represented as ISC. First we will try to calculate ISC, because in order this ISC can be calculated either using node analysis or by loop analysis. I will simplify this using node analysis. Here we can observe that we have three nodes. This is one node, this is another node, and this is one more node. I will call this node as V1, let this is V2, let this is V3. So here we can observe that node V1 is nothing but 12 volt, because 12 volt is directly connected to V1. So I can write V1 is equal to 12 volt. Call it as equation number 1. Let me assume current through this branch is say I1, current through this branch is say I2, and current here is say I3, and current here is I4. Now to calculate V2 and V3, we need to apply KCL. Let me apply KCL to node V2, that is apply KCL to node V2. We know that incoming current is equal to outgoing current. So I1 is equal to I2 plus I3, that is I1 is equal to I2 plus I3. So I1 can be expressed in terms of voltage as V1 minus V2 divided by 6K, V1 minus V2 divided by 6 kilo ohm. I2 is V2 by 2 kilo ohm, V2 by 2 kilo ohm, plus I3 is V2 minus V3 divided by 3K, V2 minus V3 divided by 3K. So now here we can observe that node V1 is directly connected to V3, therefore V3 is also equal to 12 volt. Here we can say that V3 is also equal to 12 volt. So let me simplify this further. Here V1 is 12 volt. Let me simplify. 12 minus V2 divided by, we have 6K is equal to, we have V2 by 6K, V2 by 2K, then we have plus V2 minus V3 is nothing but 12. 12 divided by, we have 3K. Let me simplify further. That is, I can represent it as 12 by 6K minus V2 by 6K is equal to V2 by 2K plus V2 by 3K minus 12 by 3K. I will simplify this further. That is, it is 12 by 6K. I take this term on left hand side, it will become plus 12 by 3K is equal to, I'll take this term on right hand side, it will be V2 by 6K plus this is V2 by 2K plus this is V2 by 3K. Further I'll simplify this. So I can represent it as 12 in bracket 1 over 6K plus 1 over 3K. On other side I can represent it as V2. I'll take V2 common. It will be 1 over 6K plus 1 over 2K plus 1 over 3K. Let me simplify this. We have 1 over 6K, that is 1. So here 6K means I will take it as 6000. And we have plus 1 over 3000, K means 1000 into 12. So it gives 6 milli, that is 6 into 10 power minus 3. 6 into 10 power minus 3 is equal to V2. Let me solve on RHS side. So we have 1 over 6K, that is nothing but 1 upon 6000. We have plus 1 upon 2000, then plus we have 1 over 3000. So it gives 1 milli, which is nothing but, I can represent it as 1 into 10 power minus 3. So simplifying this 1 into 10 power minus 3 I will take on left hand side. It will become V2 equal to 6 volts. So now we need to calculate ISC. From this circuit we can observe that ISC is the current which is moving towards V3. So at this node I3 plus ISC is equal to I4. So I can write ISC plus I3 is equal to I4. That is ISC plus I3 is equal to I4, or I can write ISC is equal to I4 minus I3. Let me simplify. ISC is equal to, so I4 can be represented as V3 divided by 4K. That is V3 by 4K minus I3. So I3 is V2 minus V3 by 3K. V2 minus V3 by 3K. Let me simplify. So V3 value is 12 volt. That is 12 divided by 4K minus. So here we have V2 is, already V2 is calculated, that is 6. So this will be 6 minus V3 is 12 divided by 3K. Let me simplify this. So this will become 12 by 4K. This will be plus 6 by 3K. Let me simplify this. Therefore IS is equal to, so here 12 by 4K means 12 divided by 4000, and we have plus 6 divided by 3000. So it gives 1 over 200, that is nothing but 5 milliamps. So ISC will be equal to 5 into 10 power minus 3 amps. So we found ISC. This shorted path must be opened and voltage sources must be short circuited. So here so to calculate Norton's resistance, now we have to open this shorted path so that this terminal will become open. This terminal will become open. Then voltage sources must be short circuited. Let me draw the equivalent circuit to calculate Rn. So here the circuit looks like this. So after calculating ISC, we need to calculate RN, that is Norton's resistance. So to calculate Norton's resistance, in this original, open this 2 kilo ohm resistor, then this terminal and this terminal will become open and the voltage source must be short circuited. The equivalent circuit looks like this. So here there was a resistor that is removed and voltage source is short circuited. Now the resistance between these two terminals is known as Rn. That is, we need to find the resistance between these two terminals. So from this circuit we can observe that 6K is in parallel with 2K and 3 kilo ohm is in parallel with 4 kilo ohm. Those two combinations are in series. Therefore I can write Rn is equal to, that is Rn will be equal to 6 kilo ohm is parallel with 2 kilo ohm and this combination is in series, means plus in series with these two combination, that is 3 kilo ohm is parallel with 4 kilo. Let me simplify this. So this is nothing but 6 kilo into 2k divided by 6k plus 2k plus here 3k into 4k divided by 3k plus 4k. Let me simplify. This will be 12 into 10 power 6 and here will be 8 into 10 power 3 plus here it will be 12 into 10 power 6 and here it will be 7 into 10 power 3. So after simplification I can write it as, so here simplifying this will get 1.5 into 10 power 3 plus here it will be 12 by 7 is, it gives 1.71, 1.71, 10 power 3 and 10 power 3, 10 power 3 will get cancelled, that is 10 power 3. So here 1.5 plus 1.77, so Rn will be 3.21. Let me draw Norton's equivalent circuit. So in Norton's equivalent circuit, this is Norton's current or ISC is connected in parallel with Norton's resistance Rn. So parallel to this, we need to connect the resistor in which current is calculating. So in this circuit, we are calculating current in 2 kilo ohm. So we are supposed to connect 2 kilo ohm in parallel to that circuit. So here connect 2 kilo ohm. This is 2k. Current through this is I naught. So here ISC is already calculated. The value of ISC is 5 milliamp and Rn is 3.21 kilo ohm. Now let me calculate I naught. So here we can apply current division rule, that is I naught will be equal to total current ISC, that is ISC into Rn divided by Rn plus 2 kilo ohm, that is I naught is equal to ISC is, we have already calculated 5 milliamp, that is 5 into 10 power minus 3 into Rn, that is 3.21, 3.21 into 10 power 3 divided by Rn, that is 3.21 kilo ohm plus 2 kilo ohm, that is 5.21 into 10 power 3. Therefore simplifying this, I'll get I naught equal to into 3.21 divided by 5.21, that is 5.21, it gives 3.08 and this 10 power 3, when it comes on numerator it will become 10 power minus 3. So I naught will be 3.08 milliamp, 3.08 into 10 power minus 3 amps. So this is the current flows through 2 kilo ohm or I naught. Thank you for watching.